I hope this helps. If it does, let me know. If it doesn't, let me know that too, and we'll adjust it accordingly. Do something a little different if we need to. All right, and away we go. Don't pay any attention to the margins because I didn't get fancy on this. The other two I'm going to do I might get fancy on, but this is just a rough cut. Question A01. What is the one way that RF energy can affect the human body tissue? Um, any tissue for that matter. But think microwave oven. A microwave oven uses RF energy. It generates microwave uh, energy. And it heats your food. It heats the body. So A is the correct answer. It heats the body tissue. B is it causes radiation poisoning. Well, we know that's not true. It causes blood count to reach a dangerously low level. That's not true. It cools the body tissue. Well, that's definitely not true. So it's the top one. It's A, heats the body tissue just like it would heat a piece of chicken. Um, all right, on to the next one. Which of the following is used to determine RF exposure from a transmitted signal? And all of these choices are correct. So on that one, when you see which of the following is used and is for RF exposure from the transmitted signal, just go down to D. It's all of the choices are correct. Not one of them, but all of them. All right. And the next one here, we'll get going here in a minute better. How can you, this is A03, how can you determine that your station complies with the FCC RF exposure regulations? Don't let this question freak you out. You could get an Elmer to help you with this, and they will walk you right through it. In many cases, just do it for you with you sitting there, and it's easy to do. There's a calculator. All you got to do is plug in the data, and it'll spit out the answer. And this again, A03, how can you determine that your station complies with FCC RF exposure regulations? And D is the correct answer. All of these choices are correct. That makes it easy because all you got to remember is I've got the 2 meter on. Is that all of the choices it gives you are correct. Number 4. What does time averaging mean when evaluating RF radiation exposure? And that answer here is D, dog. The total RF exposure average over a certain period, or a certain period of time would be a little bit more specific because it's time averaging. But total RF exposure, so not just what you got with one transmission on the microphone, but what you get for the whole time you're talking on the radio that day, for whether it be 5 minutes or 5 hours. It's the total exposure average over a certain period, and that's what time averaging means. Okay, what must you do if an evaluation of your station shows that the RF energy radiated by your station exceeds permissible limits for possible human absorption? Well, I made a stab at it. Um, and this is A05, question number 5, A05. Um, the correct answer is A. You can read through those other answers if you choose, but the correct answer is take action to prevent human exposure to the excessive RF fields. In other words, move the antenna farther away, or something where if your radio room, your shack area, is too close to the antenna, you may fall into this category. And if that's the case, move the antenna out a little further, or put it up higher, or get it further away from the people or person that's in question. All right. A. Take action to prevent human exposure to the excessive RF fields. It's a big, long question and a big, long answer. A. All right. A06. What must you do if your station fails to meet the FCC exposure exemption criteria? Now this is almost like the last question. They're all in the same family here. What do you have to do if your station doesn't meet the FCC exposure criteria, which just means what they say it's going to be? Perform an RF exposure evaluation in accordance with FCC OET Oscar Echo Tango Bulletin 65. That's what you got to do. And again, get somebody, an Elmer, to help you with this part. With the if you need it, get somebody to help you with the evaluation, the RF evaluation. Don't make it too hard, because it's not any harder than need be. All right, we'll go on to the next one. 6. What is the effect of modulation duty cycle on RF exposure? The duty cycle is the length of time that you hold down the mic key and talk, or hold down the CW key, or if you're sending CW, it doesn't count the spaces, it counts the DITs and the DAs, the total transmission, and then somebody else talks, and then you get a chance to talk again. That's a duty cycle. You say you transmit for 5 seconds, the other guy talks for 10 seconds, you transmit for another 5 seconds. That's the duty cycle, is every 10 seconds. Anyway, okay, next one. I should have shut down all those things, but I didn't. Which of the following steps must an amateur operator take to ensure compliance with RF safety regulations? This is A08. You can see it up in the left-hand corner if I forget to say it. I will redo this before I actually use it. All right. Which of the following steps must an amateur operator take to ensure compliance with RF safety regulations? Now, they've asked so many questions on this, you can tell they're serious about it. And the correct answer on this one is C. First C we've run across, but it's C. Perform a routine RF exposure evaluation and prevent access to any identified high exposure areas. So you put up a fence around it, or some kind of obstacle to keep people away from it. If it's an area like around your antennas. Suppose you had a 1500 watt 2-meter antenna situation. Then and the antenna was 4 feet off the ground, and it was a Yagi beam, a 12 element, and somebody were to walk in front of it, well, they'd probably get too much RF. So to limit that and prevent access to it, you might build a fence around it. You might raise the antenna, notify the neighbors, or something. Perform a routine RF exposure evaluation and prevent access to any high identified exposure areas. Raise the antenna, get it out of the way. Or if you can't, if that's impossible, then fence off the area. That's the reason a lot of times, I think, I don't know this for a fact, but I think that's the reason they've got the AM broadcast towers, or FM for that matter, broadcast towers fenced off. It prevents people from damaging them, being malicious and destroying them, but it also keeps the general public from walking into an RF field. So it's a twofold purpose. And the next one, where'd we go? All right, I lost my place there. Let's see. All right, A09. What type of instrument can be used to accurately measure an RF field strength? And this is B. A calibrated, there's the key word, a calibrated field strength meter with a calibrated antenna. So look for the word calibrated if you get that question. What type of instrument, what type of meter or instrument can be used to accurately measure an RF field strength? Calibrated field strength meter. And a field strength meter is probably one of the easiest things, if you choose to make one, that you'll ever make. It's basically a Zener diode and a loop of wire will work, but it's not calibrated. It'll just show you that there's RF. So you need one that's calibrated. A10, in question 10. We're nearly to the bottom of A's. What should be done if evaluating shows that a neighbor might experience more than the allowable limit of RF exposure from the main lobe of the directional antenna? In other words, if you're using a Yagi, like, and I know I pronounce it Yagi, but if you're using one like we just talked about, a 2 meter, it's got a, it's got an elliptical thing. It puts off more front ways than it does sideways or back ways. That's the reason they call it a beam. So if you're using one of those and it's got a big front lobe and the neighbor's house is in that, then here's what you do. You take precautions. Number C, A10. Number C, take precautions to ensure that the antenna cannot be pointed in their direction when they are present. There you go. You take precautions to ensure that the antenna, put a stop on your rotator. I don't know, but that's the correct answer. You could put a stop on there, and I guess, and take it off when they're gone or when they're at home, and put it on in the daytime when they're at work. That sounds like a lot of work to me. It'd be easier just to change the direction of the antenna, but it's going to prevent you. If somebody were to come along and want to transmit from your station that didn't know that, then you want to take precautions to keep that from happening. Number 11, A11, question 11 out of 12. What precaution should be taken if you install an indoor transmitting antenna? You must make sure, C again, you must make sure that MPE limits maximum possible exposures. What that exposure is, what that stands for. Maximum possible exposure limits are not exceeded in occupied areas. In other words, you put it in a different room, or if it's got to be in your room, make sure that you're not going to experience more RF exposure than is allowable by the FCC. They're going to keep you safe. And number 12, question 12. What stations, this is the last question for this sub-element, or this section of this sub-element. What stations are required, or let me start all over. What stations are subject to the FCC rules on RF exposure? All stations with a time average transmission of more than 1 milliwatt. So if you are putting out, basically, if you're transmitting anything, even QRP, then most likely even QRP, unless you're transmitting somehow less than a milliwatt, that's extremely low power. So basically, for our intents and purposes, amateur radio, everybody, all stations with a time average transmission of more than 1 milliwatt. Don't let the wording throw you off and get you frustrated. Time average transmission and milliwatt is what you want to look for. All right, that's the first half of the safety section, which comes last in order, but I think it ought to be first. But we'll pause it, and I'll come right back to you. Here we go. Um, which wire or wires in a four conductor 240 volt AC circuit should be attached to fuses or circuit breakers? Okay, there's four wires, a 240 circuit, 240 volt, There's four wires. There's a ground, there's a neutral, there's a hot, and there's a hot. One hot wire is 120 volts, and the other one is 120 volts. You add them together, you get 240 volts. So that's the way that works. So you've got two hot wires, and only the hot wires go to a breaker or a fuse. You don't have to do it to the neutral wire or the ground wire. Certainly not all wires. All right, only the hot wires. B, section B, 01. And number 2, B02, according to the National Electric Code, that's just the standard, the book. According to the National Electric Code, what is the maximum? Let me mess up. Let me start over. Beep. Edit. According to the National Electrical Code, what is the minimum wire size that may be used safely for wiring a 20 amp circuit breaker? And the correct answer is 12. AWG, American Wire Gauge number 12. So just think preteen. 12 AWG. Okay, 12 gauge. Question 3 in the B section. Which size of fuse or circuit breaker would be appropriate to use in a circuit that uses American Wire Gauge number 14 wiring? Okay, it's a little smaller wire. So D15, 15 amperes. Question 4, B04. Where should the station's lightning protection ground system be located? And this is always outside the building. Outside, that's all you need to know. You put your lightning protection, your surge protector, or your lightning arrestor on the outside of the building. Preferably close to the radio room. Get going again. B05. Which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power? Current flowing from one or more of the hot wires directly to ground. So in other words, a short. If you have a short, current flowing from one or more of the hot wires directly to ground, then it'll trip the ground fault circuit breaker. Which of the following is covered by the National Electrical Code? Electrical safety of the station. C. Electrical safety of the station is covered by the NEC, the National Electrical Code. And that's question number 6. Question number 7. We're cutting a swath here. Which of these choices should be observed when climbing a tower using a safety harness? Confirm that the harness is rated for the weight of the climber and that it is within its allowable service life. In other words, if you've got a 50-year-old climbing belt and a 55-year-old rope to go around the tower, it's probably not safe. It may look it, but it's going to have some dry rot going on, some things like that. So A. Confirm that the harness is rated for the weight of the climber. If he's a skinny guy, smaller gauge belt and stuff. If he's a big boy, then you might need a little heftier climbing belt. All right. Question B, 08. What should be done before climbing a tower that supports electrically powered devices? B. Make sure all circuits that supply power to the tower are locked out and tagged. All right. Most of these are common sense things. But this is the make sure all circuits is B. Make sure all circuits that supply power to the tower are locked out and tagged. And the locked out and tagged are the key words there. You want to look for those. B09. Which of the following is true of an emergency generator installation? The generator should be operated in a well-ventilated area. In other words, not inside a closed room. You don't want a generator in the kitchen with you, or in the living room with you, or in the bedroom with you. You'll die of carbon monoxide poisoning. So it should be operated in a well-ventilated area. If not outside, someplace that's maybe covered but caged in or something. Okay. Number 10. Which of the following is a danger from lead tin solder? Okay, if you're going to solder, what is the danger from it? Lead can contaminate food if hands are not washed carefully after handling the solder. If you do any soldering, make it a practice just to wash your hands when you're done. Go in, use a little soap and water. It's not gonna hurt you, not gonna shrink your hands or anything like that. And it'll wash that solder. It'll wash that lead from the solder off of your skin. You won't transfer it to your sandwich or something. Okay, let's see. B11. Got two more to go after this one. Which of the following is required for lightning protection ground rods? They must be bonded together with all other rods, all other grounds. They must be bonded together with all other grounds. That's the answer to B11. Which of the following is required for lightning protection ground rods? You got to bond them together with all the other grounds. If there's one more at your electrical service and one outside your ham shack, then both of them need to be bonded together with wire or cable or braid band or something like that. Something heavy duty. B12. What is the purpose of a power supply interlock? Answer C. To ensure that dangerous voltages are removed if the cabinet is opened. So that's that. And the last question. Where should lightning arresters be located? Well, they've already asked that question, just in a little bit different words. Where the feed lines enter the building. So right outside your opening, your shack window, or however you get your coax and things in the house, right outside, in the outside area, outside of the wall, you put your lightning arrestor right there. So it's close to the shack and outside to keep you safe. All right, that's it. I misspoke on the first part of the first video. Hang on just a second. Let's see where. We are. That's weird. Okay. Anyway, there are two sections here. There's section A and section B, and one covers RF exposure mainly, and the other is just electrical safety in general, lightning arresters and hot wires and stuff like that. Just general electricity questions. There's two questions on the exam. I said earlier that there's 25. That's out of both sections combined. There are 25 questions. Out of those 25 questions, you'll have two on your exam. Probably one from section A and one from section B, but not necessarily. I don't know that to be a fact. So read through them, be familiar with them, apply some common sense, because all of us have a better have a better handle on safety than we practice sometimes. Sometimes we get a little loosey goosey. All right, that is the end of the end of the section, and the element safety, which is general exam section 0, element 0. All right. See you on the next video.